So now we're moving into really looking at the relationship between the amount of product produced and the amount of reactants that you start with. In this particular lab, we want to know how do the moles of silver produced compare to the moles of copper used in a chemical reaction between copper and silver nitrate. This is another multi-day procedure, and for day 1, you will need copper wire, silver nitrate, distilled water, a large test tube, and a ring stand apparatus to hold the test tube. From the material safety data sheet, we know that silver nitrate is a white crystalline solid and a very strong oxidizer. Basically what this means is that it is irritating to all body tissues, especially the skin and the eyes. So it is very important to avoid all body contact with silver nitrate. Take your length of copper wire and wrap it around a pin. You're going to form just a coil so that the silver is going to have something to attach to. And then find its mass. Bring your test tube over to Mrs. Schroeder, and she will mass out about 1 gram of silver nitrate for you. Make sure that you record this exact mass. Take your test tube back to your lab station, put it back into the holder, then fill your test tube to within 1 inch of the top with distilled water. Using a glass stirring rod, stir until the silver nitrate is completely dissolved. This is not an immediate thing, so be patient and just keep stirring. Once dissolved, remove the stirring rod and rinse any residue back into the test tube. Add the coiled copper wire to the silver nitrate solution and let it sit overnight. On day 2, you'll need a 400 milliliter beaker, a tall 500 milliliter beaker, and more distilled water. Label the tall 500 milliliter beaker with your group name. You will also need to find the mass of your clean labeled 500 milliliter beaker. Shake the silver off the copper wire, and then remove the wire and rinse any remaining silver into the tall 500 milliliter beaker. There will be a beaker of acetone in the fume hood. Dip your copper wire into this beaker and give it a good shake. Then set the copper wire aside to dry. Pour the silver and solution into the tall 500 milliliter beaker with the silver rinsed from the copper wire. Rinse out your test tube with distilled water a couple times to make sure that you get out all of the silver. Now we're going to do a bit of decanting. So decant the solution off the silver into the 400 milliliter beaker. Rinse the silver well with distilled water at least 3 times. Be sure to break up any large chunks of silver so the water reaches all of its parts. And decant again. After the final rinse, place the beaker in the drying oven overnight. Find your copper coil and find its mass, and then put it into the leftover copper waste beaker that is in the fume hood. On day 3, mass the dry silver that's in your beaker. Then place the beaker in the fume hood and add about 10 milliliters of 6 molar nitric acid. Leave your beaker in the fume hood for the next lab. From the material safety data sheet, we know that nitric acid is a clear solution that has a fairly distinct chemical odor, kind of a chlorine type odor, very similar to hydrochloric acid. The 6 molar refers to the fact that the concentration of this acid is very high. That makes it all the more important to be very careful when using this. This does not leave the fume hood. Take your beaker to the fume hood, add it in the fume hood, and leave it in the fume hood. For cleanup, the contents of the decant beaker can go down the drain with running water. Just flush it down. Rinse your copper wire and place it in the beaker in the fume hood, and make sure you wash your hands before leaving. Be sure to take all of your data over the course of those 3 days. So before coming to lab, you need to have a few things set up in your lab notebook.